Parth. Good evening. Good evening. Hello, students from YouTube Live. Good evening. I hope everyone is well and good. How was your weekend? Parth, how was your weekend? Let me know. Acha. Nice. Mine was fine. Good. Oh, I thought it's good, but I don't know. Hopefully it was good. Jamie, tumko students, let me know, is there any unit test that is going to be conducted soon, or did the UT get completed in your case? So yeah, will be. Acha. No. I meant unit test. Unit test. Is there any unit test that is going to be conducted, not events? Okay. Good. Nice. So we'll be waiting for 2 more minutes as the students get joined. Abhay, good evening. Harish, good evening. Acha, Harish. Okay, good. When did it get completed, Harish? When was your UT? When did the test happen? And how did you do? Good evening, Abhay. Okay. So how was it? How are you, Abhay? How was the weekend? I'm fine, Abhay. Okay, good. So the time is up. So students, before going ahead, welcome to today's session. My name is Samanvit, and we were talking about what? Newton's laws of motion. Okay, we were talking about Newton's laws of motion. Very good, Harish. So in the meantime, let me know through the technical check, is my audio, is my video, that is my presentation is visible or not. Let me know, students. Okay, quickly let me know. And during the classes, if you face any issues, let me know through the text. Okay, please, students, answer the technical check. All is good. Away, thank you. But yeah, so please answer the no error. Okay, good. Okay, so almost everyone has answered. All sets. Okay, good. Thank you. Okay, everyone has answered. As there is no issue, I'm ending the poll. And yeah, same goes to YouTube live students. Okay, YouTube students. So who are joining in YouTube, if you face any difficulties during the classes like audio, just let me know. And during the classes, if you have any doubt, please drop a text message. Okay. And also after the classes, if you're not able to see the classes, and if you're seeing the class in YouTube, drop a comment. Okay, so that if any issue, we can let's say check in the next class, in the upcoming classes. Okay, good. So again, welcome to today's session, sweetie. Good evening. So students, what we were talking about? We were talking about Newton's laws of motion. So here, as you can see the picture, there is something called action reaction, right? Action reaction. So you might have got the idea that what we are going to study today. Okay, basically what we are going to study today. So in the meantime, we'll go to the contents of today's session. So what we are going to talk about today? Today we'll talk about, like, since we had two days of holidays, let us quickly recall what we were studying in the last class. Okay, then there is a homework question for you guys. You need to do it. You need to complete the homework by tomorrow's class. Okay, everyone has to do it, and I will ask each and everyone what is the answer for it. Okay, then your favorite, we'll be talking about what? Newton's third law of motion. What exactly Newton's third law of motion tells us. Then we'll talk about conservation of momentum. Okay, we have already talked about momentum. So today we'll be talking about conservation of momentum, and next we'll be talking about what? Numerical. Okay, Harish, thank you. Then we'll be talking about numerical. So students, do you remember what we have talked in the last class? Do you at least remember, or did you go through it? Do you remember, students? Let me know. In the last class, we were talking about what? Impulse. Sweetie, very good. We were talking about what? Impulse. What is this impulse? See, it says that by definition, we say that when a force acts on a body on a small what interval? Yes, Parth, very good. What? When a force acts on a body for a small interval of time, it produces a change in momentum. So we told that this change in momentum is what? Is the impulse. How did we get it? So we know that the force is equal to what? Change in momentum. And this, what we called it for a small change. For a small change, we wrote F to be what? dp by dt. Yes or no? Now, since we are talking about only for small interval of time, we got dp is equal to force into dt. And we told this small change to be what? Impulse. I hope you remember this, what? Impulse. Yes or no? Yes or no, students? Now, also see, over here, the second sentence says the same thing. Yes, very good. Impulse of a force acting on a body is a change of momentum of a body. If there is a change of momentum, this is what? Change of momentum. Momentum. We called it what? We called it the impulse. See, I told you that since this change, see, I took the example of someone hitting your face, right? अगर किसी ने मारा आपको, तो वो एक चेंज होता है ना, एक मोमेंटम था आपके पास, उन्होंने मारा, फिर आपका मोमेंटम बदल गया, लेकिन जो the force, the hitting force is only for a short period of time. Yes or no? Yes. Yes. And I told you that if you want this change in what? Change in momentum, we told it was for time t1 to t2. Yes or no? And we took it to be what? Sorry. This change in momentum is for what? T1 to T2, because we are talking about small interval of time. We told we are going to what? Integrate it. Yes. F dot dt. This is what we got for impulse. Yes. This was the formula we got for impulse. And also impulse says that if you have a graph of force and time axis, and this is the graph, then the area enclosed over here, is also the impulse. Yes or no? Where we got that, see, if I'm taking time t1 to t2, we got what? The area to be what? t1 to t2, and that is f dot dt. Yes or no? Since we are talking about the small change over here, small area, and we took it dt, and this length is f, we got this as f dot dt. And again, you know that f dot dt is what? F dot dt is what? Change in momentum. That change in momentum is impulse. Yes or no? So this is also called the impulse. This is also the impulse. Is it good, students? So we also solved certain numericals based on it. We solved a numerical based on what? Impulse. Yes. So I hope you have got the idea about what is impulse and all. Clear? Let me know, students. Is there any doubt till now? Sweetie, Madhya, let me know. Okay, good. Very good. Harish, okay, good. Now, Sweetie, very good. Okay. Now talking about what? Then we talked about what? Applications of Newton's second law of motion, where we talked about the first application to be what? Cricket player lowers his hand while catching the ball. We saw that whenever he's trying to catch the ball, what will happen? He is trying to what? Reduce the time. Yes or no? We know that force is equal to del P by del T. Always he's trying to reduce the time such that this what? Sorry, he's trying to increase the time. My bad. Reduce the time as in he's trying to increase the time, the holding time, such that the force decreases. Yes. Here also we saw that a karate player can break a pile of tiles with a single what? Single blow of his hand. Yes or no? And also with a single. Okay. This is repeated again. Yes. In a high jump athlete event, the athletes are allowed to fall on a cushion bed. Yes. So the cushion bed is basically to what? Reduce the impact. Reduce the force of impact. The force of impact. Yes. Is it good? Yes, we have seen everything about it. Yeah. Okay. Krishna, welcome to today's class session. Okay. Now, talking about the homework question that I was telling. Okay. Now, students, you need to find. See, this is a homework question. You need to do it, students. This is very, very important. Okay. So, find out the force between what? Force between these two blocks. You need to find the force. What is this force and what is the value of it? Take G to be 10 meter per second square. Okay. So, you need to find the force, which is the force that comes into picture over here. I'll give a hint over here. Which is the force that comes into picture between 2 kg and 1 kg? Harish, let me know. Which is the force? No. If see, there is a weight that is acting downwards, that I would agree. But there is a tension that is acting, right? And there is a tension acting over here also. Now the tension force, basically you need to find the what? Find the tension force, basically. Tension force. Okay. This was your hint. This is your hint. So please try to solve it. Okay. Everyone has to try to solve it. Tirth, okay. Good evening. Welcome to today's session. Okay. Now, talking about the interesting thing that we are going to talk about today. That is what? Newton's, yes, very good. Newton's third law of motion. Everyone have heard about Newton's third law of motion. Yes or no? If that is the case, I'll go to the next slide. But do you know what does the third law says? Harish, very good. What does the third law say? Do you remember? You have you have used that line everywhere. है ना? हाँ. So what does the Newton's third law says? See, according to Newton's third law, to every action there is always an equal and opposite reaction. ठीक है? क्या? To every action there is an equal and opposite reaction. ये जो action reaction है, basically people try to what? Misinterpret it. जैसे मान लो किसी का नाम अभय या तीर्थ जो भी है, ठीक है, तो उन्होंने ऐसा बोल दिया, सर अगर किसी ने मुझे मारा वो एक एक्शन है, तो मैं रिएक्शन में क्या क्या करूंगा? आई विल से हिट हिम बैक. दिस यू वुड से, राइट? यस और नो? बट दिस इज नॉट एट ऑल राइट टू से कि अगर आप किसी ने मारा तो आप क्या बोल रहे हो कि थर्ड लॉ की वजह से मैं भी मारूंगा? नहीं, आप ऐसा बोल नहीं सकते. क्यों? I'll tell you. Okay. Now, if I'm keeping a mass on a surface, okay, let me know what are the forces acting on the mass. ये बताओ पहले. Forces. Yes, very good. अगर मैं FBD on the mass करूंगा तो on the mass तो कौन सा आएगा? We know that there is this mass m and we know that there is a weight that is acting. Yes, VT, very good. Parth, very good. mg, and also a normal force that is acting by the surface on the object. Yes. Now the second question would be FBD on the surface कौन सा आएगा? फिर FBD में कौन सा फोर्स आएगा? ये बताओ पहली बात तो. सरफेस में अगर सरफेस का करूंगा तो लेट मी नो स्टूडेंट्स. नो अबे, जस्ट थिंक. सरफेस में कौन सा आएगा? वेट तो नीचे हो रहा है, वो अलग बात है, लेकिन यस, वेरी गुड. व्हाट? द नॉर्मल फोर्स दैट इज एक्टेड बाय द व्हाट? मास ऑन द सरफेस. यस और नो? यस. देखो यहां जब आप मास को हम okay, yes, very good. See, when we are trying to consider mass, when we are trying to consider mass over here on the surface, see over here, this normal force by the surface on the mass and this normal force by the mass on the surface is the action reaction force. Is the what? Action reaction force. अब पता चला? See, over here there is some interesting things about this action reaction force. Okay, what are those things? What are the, like, you need to note it down when you're trying to talk about the action reaction force. अब पता चला ना? देखो, before talking about this point, let me draw this mass again. Okay, there is this mass. You know that there is a weight acting. Weight is equal to m into g. And also you know there is a normal force acting. There is a normal force acting by the surface. अगर ये surface है, अब आपको ये भी पता है कि ये जो है force है वो n m s है. ठीक है. See, this is very very important. ठीक है, ये आपको याद रखना ही पड़ेगा. ठीक है, देखो, the first point says both action reaction occurs at the same time. देखो, जो ये normal force है that is acting on the surface, on the mass by the surface, and the normal force acting on the what surface by the mass are acting on the same time. Yes or no? Acting on the same time, है कि नहीं? Yes or no? देखो, मैंने सरफेस पर रखा, इस मास को सरफेस पर रखा, ये मास है, इसको सरफेस पे रखा, तभी वो एक नॉर्मल फोर्स लगेगा ऊपर और नीचे, सरफेस की वजह से और मास की वजह से. लेकिन जैसे आपने बोला कि हाँ सर मैंने किसी को मारा क्योंकि उसने मुझे मारा, लेकिन वो सेम टाइम पे हो रहा है, ये बताओ वहां वो सेम टाइम पे हो रहा है कि नहीं हो रहा है? The one, let's say you're trying to hit someone, you said that sir, his action, due to his action, yes, very good, his action, you gave a reaction. Ganesh, is there any doubt? Harish, very good. So yeah, so what? So that is the reason whenever you're trying to say that, ठीक है, वो मजाक में बोलने के लिए सही है, ठीक है, लेकिन लेकिन क्या, लेकिन जब आप नॉर्मल एक्शन रिएक्शन फोर्स के बारे में बात करते हो ना, then it is not right, or let's say it's not valid to say that that is action reaction force. Okay, now after this is the second point. What? Both action and reaction act on different bodies, है कि नहीं? देखो, ये मास है, जब मास के एफबीडी बना रहा हूं, मास के एफबीडी बना रहा हूं, ठीक है, ये सरफेस था, एक वेट था, ये जो नॉर्मल फोर्स है वो एक्टिंग कर रहा है सरफेस ऑन द मास. यस और नो? अब जो मैं सरफेस के कर रहा हूं, अगर मैंने सरफेस के किया तो ये जो नॉर्मल फोर्स है इज एक्टिंग ऑन द सरफेस, सॉरी, इज एक्टिंग ऑन द सरफेस बाय द मास. यस और नो? ये दोनों जो नॉर्मल फोर्स है इज एक्टिंग ऑन डिफरेंट बॉडीज. यस और नो? पार्थ, लेट मी नो. Tumkur students, let me know. Madhya, let me know. Very nice. Sweetie, Tirth, Krishna. Yes, very good. Ha. This is the second point. Now the third point. The force always exists in pairs. देखो, पहली बात तो अगर मैंने इस मास को रखा, ठीक है, और आपको पता है कि अर्थ है, ठीक है, ये वाला अर्थ है, और आपको पता है कि एक वेट एक्ट कर रहा है, वेट इज इक्वल टू m into g, और ये एक्ट कर रहा है दैट व्हाट नॉर्मल ऑन द बाय द सरफेस ऑन द मास एंड नॉर्मल on the by the mass on the surface. Now let me know students, ये और ये पेयर हो सकता है क्या? ये नॉर्मल फोर्स और ये जो वेट एक्ट कर रहा है पेयर हो सकता है क्या? नहीं ना. That is what always the action and reaction will always be what in pairs. ये दोनों पेयर्स में होंगे. Always remember, ये और ये पेयर्स नहीं है ना. Those forces are not pairing forces. Yes, उसको पेयर नहीं बोल सकते. पेयर क्या होता है? सिमिलैरिटी होता है ना, सिमिलर होता है. यस, वेरी गुड, वेरी गुड. अब देखो एक और पॉइंट है. व्हाट डज द अनदर पॉइंट सेज? द एक्शन रिएक्शन पेयर आर ऑफ सेम नेचर. अब देखो, सिमिलरली यहां मास था, यहां नॉर्मल फोर्स था ऑन द सरफेस. मुझे ये बताओ, ये कौन सी फोर्स टाइप ऑफ फोर्स है? ये कौन सी टाइप ऑफ फोर्स है? ये ग्रेविटेशनल फोर्स है ना, ये ग्रेविटेशनल फोर्स है ना. और ये क्या है? ये वाला तो कांटेक्ट फोर्स है, कांटेक्ट फोर्स है. तो पहली बात तो ये सेम टाइप, सेम नेचर की नहीं है, तो ये तो पेयर ही नहीं बना सकता, है कि नहीं? द पेयरिंग कैन बी हैपन इफ दे आर व्हाट ऑफ सेम नेचर. व्हाट? सेम नेचर. अब समझे? इज इट गुड? लेट मी नो स्टूडेंट्स. यस, लेट मी नो. या यस कृष्ण, ओके, गुड गुड. अब देखो, अब हमने टेंशन के बारे में बात किया था ना, वी वर टॉकिंग अबाउट टेंशन। ये देखो, अगर मैंने मास इधर रखा है, एक मास, ठीक है, एक वेट एक्ट करेगा m इंटू जी। ये बताओ अगर मैं यहां खड़ा हूं तो वेट कहाँ एक्ट करेगा, सॉरी टेंशन कहाँ एक्ट करेगा? लेट मी नो, लेट मी नो स्टूडेंट्स। टेंशन, यस टेंशन इधर एक्ट करेगा, अपसेट, यस वेरी गुड, वेरी नाइस। हाँ, और इधर रहूं तो टेंशन इधर एक्ट करेगा, यस और नो? नाउ इस टेंशन दैट इज एक्टिंग, सी टेंशन हियर इज सेम, tension is same due to what? due to due to what? same string, same string। मुझे ये बताओ, ये दोनों नेचर सेम है, इसका नेचर सेम है, यस और नो? और जो भी ये टेंशन एक्ट कर रहा है, जो टेंशन, ये टेंशन एक्ट कर रहा है इस मास पे, ये टेंशन एक्ट कर रहा है इस मास पे, तो एक और है कि टेंशन इज एक्टिंग, टेंशन इज एक्टिंग, एक्टिंग ऑन डिफरेंट डिफरेंट बॉडीज, यस और नो? ये भी सही है। और क्या था कि बोथ एक्शन एंड रिएक्ट ऑकर्स एट द सेम टाइम। ये जो टेंशन है, दीज टू एक्ट एट सेम टाइम, एट सेम टाइम, ये भी सही है हमारे पास। एक और है कि व्हाट, देयर फोर्स एग्जिस्ट ऑलवेज इन पेयर्स। ये जो फोर्स है, ये जो टेंशन फोर्स है, ये दोनों टेंशन फोर्स है, ये दोनों पेयर है ना, बेसिकली पेयर्स है ना। तो कैन आई सेल टेंशन इज अ action reaction force, tension is a action reaction force, yes, yes, very good, very nice, okay, that is the case. So always remember to students, tension is what? A action reaction force। सही है सब कुछ? did you get it now? So whenever you're talking tension, अब पता चला ना कि टेंशन हर टाइम पेयर में होनी चाहिए। अब पता चला कि अगर कुछ दिक्कत आ रहा है ना, तो ये सब याद रखो। इज इट गुड? यस, वेरी नाइस, वेरी गुड। Okay, others, let me know in the chat. Jenny, Tumkur students, is there any doubt? Harish, very nice. Oh, very nice, very good, very good. Ha. Now if you have talked about the Newton's third law of motion, third law के बारे में हमने बात कर ली सब कुछ। Now we'll be talking about something, what? Application of third law. Okay, application of third law. What is this application? See, we know that there is what? For a action, there is a reaction force, ठीक है? ये वीडियो है, ये वीडियो में दिखाऊंगा। लेकिन ये बताओ स्टूडेंट्स, अगर मान लो एक बुलेट यहाँ से चल, मतलब if I'm firing a bullet from a gun, so what will happen? Okay, तुमको स्टूडेंट्स, very good. See, there is a bullet that is coming out from this. Okay, if I'm trying to what, fire a bullet, what will happen? Like, अच्छा, okay, very good, very nice. Others, let me know. इसके बारे में डिटेल भी बात करेंगे, लेकिन ये बताओ कि अगर मैंने एक गन से, ड्यू टू फोर्स ऑफ विंड, ओके वेरी नाइस। देखो यहां देखो कि इस वीडियो के सही से देखो, दिस गाय इज ट्राइंग टू व्हाट, फायर अ बुलेट। ओके, व्हाट इज हैपनिंग? सी, ही इज ट्राइंग टू फायर अ बुलेट, यस और नो? ये थोड़ा स्पीड है, लेकिन देख लो, या? सो व्हाट इज हैपनिंग ओवर हियर? यस, over here you can see that what, whenever he is trying to what, fire a bullet from the gun, तो क्या हो रहा है कि एक रिकॉइल हो रहा है ना, मतलब क्या हो रहा है कि एक फोर्स पीछे आ रहा है। सो बेसिकली दिस फायरिंग गन, कैन आई से इट एज एक्शन, एंड देयर इज अ रिएक्शन फोर्स, पता चला ना कि थर्ड लॉ कहां अप्लाई कर रहा है? The first application is what? Recoiling of gun. There is a action and a reaction force. Yes. Very good. Yes. Now talking about other application. The second application. देखो, while running, we press the ground in backward direction with foot. देखो, अगर आप whenever you're trying to run, you're basically applying a force to the gun, yes or no? to the, towards the, like to the ground. Yeah. Now the runner basically pushes back and down on the ground. Yes or no? He's trying to push the ground and try to run. So एक force लगेगा F. Now, whenever the runner is trying to push the ground, there is an equal action force. That is what ground pushes forward and up on the run. Is it good? That is why we are able to run, students. यहाँ भी third law apply कर रहा है ना? Third law is being applied. Is being what is applied over here? Is applied. Is it good? पता चला एक और application अभी. ತೀರ್ಥ ಕೃಷ್ಣ ಲೆಟ್ ಮಿ ನೋ. ಅರ್ಥ ಆಯ್ತಲ್ಲ? ಯಾರಿಗಾದ್ರೂ ಅರ್ಥ ಆಗದಿದ್ರೆ ಹೇಳಿ. Will be pushed. Okay, Harish. Yes, very good. Can anyone give another example of third law? I'll go to the next example, but अभी कुछ याद आ रहा है? कोई भी अगर आपको पता है कि याद है कि हाँ यहाँ third law apply हो रहा है. Can anyone say me? जल्दी जल्दी अगर याद है तो. See, do you remember? देखो, most of you would have gone to what the boating. Yes, very good अभय. See, most of you have gone to boating. Yes or no? देखो, जब भी आप बोटिंग पे जाते हो, बोटिंग करने के बाद रिटर्न आने के बाद जब आप यहाँ मतलब लैंड पे आने चाहते हो, you will try to push the boat and come up. Yes or no? So basically there is a force on the boat by you, and this what boat will also apply a force on the man. इसलिए आप यहाँ चढ़ सकोगे, वरना that is why if there is no action reaction force नहीं होगा ना, then you wouldn't be able to come to the land. Yes or no? If the boat doesn't push with the force, yes, see, you will think that you are trying to push the boat, but there is an equivalent there is a force. There's an action reaction force basically. Okay, there's an action reaction force basically. Let's say if this is the positive side and this is the negative side, okay, now you are applying force. The human is trying to apply a force, and there is a equal force applied by the boat on you. Is it good? Yes. Swimming, yes. Krishna, very good, very nice. These are everywhere you will find it. Okay, everywhere. The fourth application would be what? A rubber ball rebounds when struck from the ground. Yes or no? अगर आप बॉल में खेल रहे हो and if you're trying to hit the ground with the ball, the ground will apply a reaction force. Basically, there is a reaction force. There is a reaction force by the ground. It's good. Very nice. Very nice. Okay. अभी तक सब कुछ समझ में आया? थर्ड लॉ पता चला आपको कि जो भी फोर्स होगा ना, अगर आप एक फोर्स अप्लाई कर रहे हो, there is a reaction force that is being applied but in the opposite direction. Is it good? यहाँ तक सब कुछ सही है? Let me know, students. Let me know jaldi with the thumbs up or anything. Parth, Madhiya, तुम good students. Yes, flying a rocket, Krishna, yes, but there is another concept that comes into picture. Okay, that we are going to talk about now. Okay, is it good? Yes. Now coming into a concept which is very important, that is what? Conservation of linear momentum. ये तो आपने सुना ही होगा, लेकिन ये बहुत ही important concept. Okay, important concept. Now, you know that what is the formula for momentum? P is equal to what? P is equal to what? Let me know. What did we get for momentum? P is equal to okay, F by A. No, I'm talking about the that is acceleration. That is acceleration you're talking about, or mass. What is F by A part? I didn't get you. What is F by A? What is A? What is F? Krishna, very good. Yes, Sweetie, very good. That is what P is equal to M into V. Now, Okay, yeah, force per unit. You're talking about force per unit area. Okay, okay, good. So I was talking about P is equal to M into V. Okay, we'll be talking about these things only here. So let's not complicate things. Okay, let's talk about those things also. Don't worry. Now, let us take a scenario where see, I have two masses. Okay, mass one and this is mass two. Okay, ये वाला mass two है. Now, these two masses are moving towards each other. Are what? Moving towards each other. ठीक है, मतलब ये इधर मूव कर रहा है और ये इधर मूव कर रहा है. ओके, नाउ विद द वेलोसिटी ऑफ व्हाट u1 एंड u2. क्या हुआ? u1 इज द व्हाट? वेलोसिटी ऑफ मास m1 and what is u2 is the velocity of mass m2. ठीक है. Now you know that this has mass m1 and this has mass m2. Now if they're coming towards each other, what will happen? अगर दो masses है वो रोल करते 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 नीचे पास आ रहे हैं तो क्या होगा? What will happen to the masses? What might happen? Yes, so they will collide. Yes or no? They will collide. Now let me know students, if they're colliding with each other, तो क्या हो रहा है कि एक फोर्स लग रहा है ना, बेसिकली एक फोर्स लग रहा है by this mass f1 and there is a force that is applied by this mass f2. Yes or no? Force applied by mass m1 on m2 and what? Yes, force applied by mass m2 on m1. अब ये बताओ, अगर एक फोर्स लग रहा है तो क्या होगा? If there is a force, then according to Newton's second law क्या हो सकता है? अगर जो फोर्स लग रहा है वो जीरो नहीं है तो क्या होगा? Let me know quickly. Let me know students. हाँ, वेरी गुड स्वीटी. क्या होगा कि एक एक्सेलरेशन भी होगा. ऐसा नो, एक्सेलरेशन विल नॉट बी जीरो, देयर विल बी अ acceleration. Very good. Acceleration. Very nice. So what will happen? See, there will be a force applied by both the masses on each other. Now due to this force there is a acceleration. Yes or no? जब collide होने के बाद, after colliding, yes, आफ्टर कोलाइडिंग, ये कोलिजन होने के बाद, ये जो कोलिजन है, ओके, कोलिजन के बाद क्या हो रहा है कि एक एक्सेलरेशन आएगा. वो एक्सेलरेशन क्या होगा? a1 एंड a2 होगा. नाउ देखो, जो भी कोलिजन होगा एक टाइम t1 और t2 होगा. ऐसा नो, मुझे ये बताओ, द फोर्स अप्लाइड बाय both the bodies will be for same interval of time. Yes or no? Interval of time. Yes or no students? जो भी फोर्स लगेगा ना, जो फोर्स F1 लगा रहे हैं ऑन मास व्हाट M2 एंड जो भी फोर्स F2 मतलब M2 लगा रहे हैं मास M1 में, वो टाइम सेम होगा ना? द टाइम विल बी सेम और डिफरेंट? टाइम सेम होगा या डिफरेंट होगा, ये बताओ मुझे. हरीश, लेट मी नो. Others, let me know. Parth. Very good. Krishna Tirth. Yes. So the time T1 is equal to T2. ये बोल सकता हूँ. The time will be same. Now you know that. See, this force. Let's say this side we are considering positive side, and this side I'm considering what? Negative side. Then therefore from third law आपको क्या पता है? From third law आपको क्या पता है? Let me know. कि जो भी फोर्स होगा F1 वो होगा माइनस F2. Yes or no? एंड आपको पता है कि फोर्स की वजह से एक एक्सेलरेशन होगा m1 a1 is equal to minus m2 a2. Yes. Now can I, you know that what is acceleration? Acceleration is basically what? Change in velocity with respect to time. So can I write v1 minus u1 by t1 is equal to m2 into v2 minus u2 by t2. ये लिख सकता हूं. Yes or no? Very nice. Others, now you know that t1 is equal to t2, so t1 and t2 cancels out. Then I get what? m1 v1 minus m1 u1 is equal to m2 v2. Okay, now here एक चीज आपको करना पड़ेगा. देखो, आपको यहाँ एक माइनस साइन छूट गया ना, यहाँ एक माइनस साइन था, है कि नहीं? मेरे से माइनस साइन छूट गया, या there will be a what? Minus sign. Just a second, I'll just write it clearly. Is equal to what? Minus of m1 m2. So ये क्या होगा? Minus m2 v2 plus m2 u2, है कि नहीं? जब मैं इसको रीअरेंज करूंगा तो ये ऐसा हो जाएगा ना. If I bring over this over here and this over here, then m1 v1 plus m2 v2 is equal to m1 u1 plus m2 u2. ऐसा कुछ हो रहा है क्या? देखो, आपके पास क्या आ गया कि जो फाइनल आ रहा है वो m1 v1 plus m2 v2 is equal to m1 u1 plus m2 u2. ऐसा कुछ आ रहा है क्या? देखो, ये जो आ रहा है इसको मैं कोलिजन व्हाट मोमेंटम बोल सकता हूं. ये मोमेंटम है, सिस्टम का मोमेंटम है, और ये भी मोमेंटम है. लेकिन जो ये मोमेंटम है ये सिस्टम का है ना, सिस्टम का. बट दिस मोमेंटम इज बेसिकली व्हाट आफ्टर कोलिजन. और जो ये मोमेंटम है, जो ये वाला मोमेंटम है, जस्ट अ सेकेंड, ये जो मोमेंटम है बिफोर कोलिजन है कि नहीं? Yes or no? So can I write total collision after collision? Sorry, total. Just a second, my bad. देखो, total momentum after collision is equal to total momentum बिफोर कोलिजन. लिख सकता हूं ऐसे में? लेट मी नो स्टूडेंट्स, ऐसे लिख सकता हूं? देखो, हमने वही प्रूव किया ना. यस, नाउ दिस इज द लॉ ऑफ कंजर्वेशन ऑफ मोमेंटम सेस. लॉ ऑफ कंजर्वेशन ऑफ मोमेंटम says. Okay, now see, always remember here we have assumed that the assumptions or assume that there is no external force, है कि नहीं? देखो, यहाँ जो फोर्स आ रहा था ना वो तो इंटरनल फोर्स है. ये दोनों हो रहा है वो कोलिजन की वजह से हो रहा है ना, ये इंटरनल फोर्स है. इज देयर एनी एक्सटर्नल फोर्स? एक्सटर्नल फोर्स कुछ लगा है क्या? नहीं ना, कुछ भी एक्सटर्नल नहीं है. जब हम एक्सटर्नल फोर्स नहीं लगा रहे, then what we get, the total momentum of the system before collision is equal to what? Total momentum of the system after collision. And this is the what law of conservation of momentum says basically. जब भी आपका सिस्टम क्या एक आइसोलेटेड सिस्टम होता है बेसिकली, मतलब एक्सटर्नल फोर्स मतलब आइसोलेटेड सिस्टम. Whenever there is an isolated system, then the total momentum of the system what is remain conserved. अब पता चला? Let me know students. I'm giving you 2 minutes to grasp everything that we have studied till now. ठीक है? क्या हो रहा था? दो masses थे. They were trying to do what? They were approaching each other. Then they collided. Now before collision, you know that there was certain what momentum of each of the bodies. That is total system K. Now after collisions there is certain velocity, what there is certain acceleration, you know, because of the force. Now whenever we are trying to see, we know that from the third law, whenever there is like whenever there is an action, what force, there is a reaction force. So based on that we got it, f1 is equal to minus f2. Then based on what acceleration, f is equal to m1 into m, f is equal to m into a basically. And for each bodies, if we apply, we get m1 a1 is equal to m2 a2. Yes, and we know that acceleration is basically what? Rate of change of velocity. And we got the final equation as what? This as your final equation, which is very, very important. Yes. Let me know, students. Is it good till now? Let me know. Others, let me know. Yes, Abhay, very good. Parth, Tirth, Sweetie. Very good. Tumko students? Okay, very nice. Now, that is what conservation of linear momentum is. What? The total momentum of a isolated system. Matlab kya? There is no external force on it. External force being applied on it. Of an interacting particle is what? Conserved. Yes. So that is what? If there is no external force acting on a system, the total momentum remains conserved. Yes or no? देखो. What is this isolated system? अब आपको पता है कि मान लो अभी कोविड का सिचुएशन है, तो अगर आपको कोविड हो गया तो क्या करना पड़ेगा? आइसोलेशन करना पड़ेगा. Yes or no? आइसोलेशन का मतलब क्या है कि आप हर तरफ से बंद हो, आपके ऊपर कुछ भी इंटरेक्शन नहीं होगा ना, कि जो भी फोर्स है कुछ नहीं होगा, सिर्फ आप ही हो. Yes or no? In isolation. कोविड का आइसोलेशन पता है ना? हाँ, वेरी गुड. तो वही बता रहा है, ठीक है ना? इज इट गुड? आइसोलेशन का मतलब वही है कि एक्सटर्नल फोर्स कुछ भी नहीं है. या सो फॉर आइसोलेटेड सिस्टम द इनिशियल मोमेंटम ऑफ द सिस्टम इज इक्वल टू द फाइनल मोमेंटम ऑफ द सिस्टम. ये हमने अभी देखा. दैट इज व्हाट? m1 u1 प्लस m2 u2 इज इक्वल टू m1 v1 प्लस m2 u2. ये बहुत ही ज्यादा ही इंपॉर्टेंट है स्टूडेंट्स. प्लीज रिमेंबर दिस. Please remember this. Okay, very, very important. Good. Till now, अभी तक सब कुछ समझ में आया? Very good. If that is the case, students, then we are going to what? Numerical. ये numerical आपको solve करना पड़ेगा. This is very, very easy. Okay, देखो. पहला numerical. What is this numerical says? A bullet of mass 5 kg. ठीक है. आपके पास एक गन था. ठीक है. मेरा गन इज वेरी बैड. ठीक है. वेरी बैड गन. ठीक है. आपके पास एक गन था. ठीक है. और एक बुलेट आपने फायर किया. ठीक है. अब बुलेट जो इसका मास था वो था 50 kg, 50 ग्राम्स विद 35 मीटर पर सेकेंड. इफ द मास ऑफ द गन इज व्हाट? ये जो गन है इसका जो मास है वो है 4 kg. देन कैलकुलेट द रिकॉइल वेलोसिटी ऑफ द गन. आपको पता है कि जब आप फायर करते हो एक रिकॉइल वेलोसिटी होता है ना. दैट इज व्हाट यू नीड टू फाइंड इट आउट. फाइंड आउट कर सकते हो? लेट मी नो स्टूडेंट्स. ओके, आई एम गिविंग यू 2 minutes ऑफ योर टाइम टू सॉल्व दिस. ओके, अब ये सॉल्व कर सकते हो. ये बहुत ही ज्यादा इजी है. प्लीज लेट मी नो. अच्छा, हाँ इधर है स्टॉप वॉच. ओके, so is the timer, students? Please try to solve it. Tumko students, you need to solve it. Okay, everyone. And I want to know what is the answer for it. Harish, please solve it. YouTube students, everyone has to solve it. ठीक है. अगर ये आपने solve कर दिया ना, ये बहुत ज्यादा easy. Abhay, I want the velocity basically. Parth, very good. देखो, this is what based on. I'm giving a hint more. See, अभी हमने conservation of momentum. देखो, heading ये बोल रहा है कि what? Numerical based on conservation of momentum. So you need to apply you need to apply law of conservation of momentum. Law of conservation of momentum. थोड़ा दिमाग लगाओ, फिर हो जाएगा. Okay. No, Tirth, I want the velocity, not the force. Very good. Abhay, very good. Others, let me know. Harish, no. Sandesh, please check your answer, and Harish, please check your answer. Very good. Okay, everyone is trying, so we're doing very good. जो भी आप solve कर रहे हो ना. Tirth, just a second. Yes. So let me know the unit also. Abhay and Tirth, you have given the same answer, but I want to know the unit of it. Is there any unit that comes into picture, or is any 10 to the power something that comes into picture? Let me know. Okay, Parth, very good. Abhay, no, that is not the unit. Okay, the time is up. Abhay, very good. Okay, very nice. Janvi Tumku students are the one who gave the right answer, the correct answer. Others have given the answer, but there is small mistake in it. I'll tell you the mistake. Okay, I'll tell you exactly the mistake. See, over here, jab before firing, yeah, firing of the bullet, मुझे ये बताओ कि बुलेट रेस्ट में था. यस, बुलेट क्या जो ये बुलेट नहीं, क्या वो जो फायरिंग का बुलेट है वो रेस्ट में था. Was it rest? अगर रेस्ट में है, will it have any momentum? ये बताओ मुझे. Let me know, students. There will be any momentum? No. So the initial momentum is what? 0. Yes or no? अब आपको पता है कि जो आपने ये लॉ ऑफ कंजर्वेशन ऑफ मोमेंटम की जो आपने अभी देखा है. So we are talked about what? Law of conservation of momentum. From that, we know that what? Initial momentum is equal to what? Final momentum. अब आपको पता चला कि जो initial momentum है वो तो 0 है. तो what? The final momentum is equal to 0. Yes or no? Now, you know that after firing के बाद ये जो बुलेट हो रहा है वो एक वेलोसिटी से क्या मूव करेगा. Then you know that there is a what? Recoiling velocity also. Yes or no? Yes. Now we know that this final what? Pf is equal to 0. That is the final momentum. So can I write m1 what? V1 plus m2 V2 equal to 0. This is the final momentum. Yes or no? System ka, because system's final velocity. Now over here we know that, let me consider जो गन का जो, okay, just a second. देखो, जो गन का मास है ना उसको मैं m1 ले लेता हूं, और ये वेलोसिटी है इसको v1 लेता हूं 35 मीटर पर सेकेंड. Yes. Now let me take, so this is for bullet, this is bullet. Okay. Now for gun, let me take m2 as what? 4 kg. Okay. And v2 we need to find out. Now over here we want what? V2. Now so can I write v2, that is m2 v2. Okay, just a second. अच्छे से लिखते हैं ना, बहुत अच्छे से. m2 v2 is equal to minus m1 v1, and I want v2 which is equal to minus m1 v1 by m2. Yes or no? Now we want what? Yes, Parth, very good. Yes, we'll convert. I'll talk about it. That is also right. Now see, जो मास गिवन है m1 का वो 50 ग्राम है, और m2 का मास है वो क्या है? 4 kg है. ऐसा नो, एक 4 kg में दिया है, एक 50 ग्राम में दिया है. So let me convert this into what? Kg. इफ आई एम कन्वर्टिंग इनटू केजी कितना आएगा, देखो आपको पता है कि 1000 ग्राम में कितना कितना केजी है, 1 केजी है, तो 50 ग्राम में कितना होगा ये आपको फाइंड आउट करना पड़ेगा। आपको पता है कि अगर 50 ग्राम है तो क्या आएगा, 50 इंटू 1000, सॉरी 50, जस्ट अ सेकेंड, 50 बाई 1000 है ना, 50 बाई 1000, सो कैन आई राइट इट एज 50 इंटू 10⁻³ kg, लिख सकता हूं मैं। So I will get m1 in terms of kg as 50 into 10⁻³ kg. Yes. Now you have everything. Now substitute over here. V2 is equal to minus what? m1, that is 50 into 10⁻³ फिर क्या आएगा, students? Let me know. Am I audible, students? Let me know. Is my audio is clearly audible or not? I have a small doubt. Yes. Okay, sweetie. Okay, good. Okay, good. So minus what? देखो माइनस एक बचा है ना, आप लोगों ने माइनस नहीं लिखा। 50 into 10⁻³ वेलोसिटी कितना था, वेलोसिटी वाज 35 मीटर पर सेकेंड डिवाइडेड बाय कितना आएगा, ये m2 मास इज व्हाट 4 kg, और इसका जो आंसर आ रहा है ना v2 कितना आ रहा है अभी आप बताओ, इसका जो आंसर आएगा माइनस व्हाट, माइनस 0.437 मीटर पर सेकेंड, and this was given, this is your answer. अब पता चला? Yes. And JNV तुमको students are the one, तुमको students ना, let me know how the ನೀವೆಲ್ಲ ಆನ್ಸರ್ ಕೊಟ್ಟದ್ದು yes are the ones who gave with the right answer, that is what minus, with the minus. So clap for yourselves. Okay, very good. So that shows that it's clearly understood and you are not missing these points. देखो आपको भी पता है जो रिकॉइल हो रहा है ना, वो रिकॉइल हो रहा है, वो तो पीछे जा रहा है ना, दैट इज अ व्हाट रिकॉलिंग वेलोसिटी। सो आगे जाने वाला अगर मैंने पॉजिटिव लिया तो पीछे जाने वाला क्या नेगेटिव लूंगा, तो ये सब याद रखना पड़ेगा। नेवर मिस दिस साइन, ठीक है, साइन फिर यूनिट, ये सब यू शुडंट मिस। सो तुमको स्टूडेंट्स वेरी 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 गुड। ओके, नाइस। ओके, समझ में आया अभी तक? संदेश let me know, हरीश let me know, students. थोड़ा गला खराब है, okay, so bear with me. Okay, good. Nice. Now if that is the case, here is another question. Okay, here's another question. The question says two objects of mass 5 kg, ठीक है, दो मास है of 5 kg each, ठीक है, and moving in the same straight line but in opposite direction towards each other with same speed. जो भी इसका स्पीड है वो है 3 मीटर पर सेकेंड है और इसका 3 मीटर पर सेकेंड, ठीक है। दे स्टिक टू ईच अदर आफ्टर कोलिजन, ठीक है, इसके बाद कोलिजन हो गया, कोलिजन के बाद ये दे स्टिक टू ईच अदर, ये 5 kg है, ये 5 kg है, ठीक है। व्हाट विल बी द वेलोसिटी ऑफ कंबाइंड ऑब्जेक्ट आफ्टर कोलिजन? देखो आफ्टर कोलिजन एक एक्सेलरेशन होगा, ये इस साइड भी हो सकता है, इस साइड भी हो सकता है, जो भी वेलोसिटी आएगा ना उसको आपको फाइंड आउट करना पड़ेगा, वो वेलोसिटी क्या है। लेट मी नो स्टूडेंट्स। सो आई एम गिविंग यू व्हाट 3 minutes of time. ये थोड़ा ट्रिकी है but it is very easy. Okay, so I'm giving you 3 minutes of time to solve this, students. After that I'll solve it. Okay, so here is the time. Let me know, students. And yeah, in the meantime, students, please answer the NPS. ठीक है, please answer the NPS. Let me know how is my class going. Is there anything that I have to do it better? Okay, so don't worry, I will work hard to make sure that you guys understand everything. If that is not the case, yeah, please let me know in the chat. Okay, let me know. Amrita, Harish, hello Amrita, let me know the answer for it. Okay, yes, everyone please answer the NPS. Abhay, very good Abhay, ठीक है, tap your back. That is a very quick and a very precise, very good answer. सही आंसर दिया है। पता था क्या पहले से या अभी सॉल्व किया है? एवरीवन हैज टू आंसर द एनपीएस, ठीक है? तुमको स्टूडेंट्स यू आल्सो हैव टू आंसर द एनपीएस, प्लीज आंसर द एनपीएस। In the meantime, while solving also, please answer the MPS. Okay, very good. तुमको students very good, very nice. Parth, very good. Amrita, no. Check your answer, Amrita. And YouTube students also, please let me know how is my class going. Is there any changes that has to be made? Okay. Harish, no, that is not the right answer. Sweetie, let me know the answer. Madhya, let me know the answer. ये बहुत इजी है, ठीक है, लेकिन थोड़ा ट्रिकी है. Sweetie, no. Please check your answer once. हरीश, नो नो. हरीश, थोड़ा ध्यान रखो. Like check the question once. What does the question says? Amrita, also please check the answer. Okay. Okay. I'm going to solve it. Okay. I'm going to solve it. Dekho. Now, see, you know that right now over here, two objects are moving with the velocity, right? With the same velocity and with the same mass. Now, let me know, students, will the initial momentum be zero? Let me know. Will the initial momentum be zero? No, right? Okay. Sweetie. Acha, it's very simple. Sweetie, no. See, over here, the two masses are what? They are what? See, initial momentum is not zero, sweetie. Why? Because over here, objects are moving. Objects are moving. You know that P is equal to M into V. But if V is zero, then the momentum becomes zero. But over here, the objects are moving, so velocity is not zero. Now, you know that initial momentum of the system is what? M1 U1 plus M2 U2. Now you know that over here M1 is what? 5 kg. U1 is equal to what? 3 meter per second. And you know that M2 is what? M2 is what? 5 kg. And U2 is what? 3 meter per second. But over here, let me know, or let me ask you, isn't it this mass traveling in the opposite direction of this mass? Let's say this is body 1 or this is body 2. This body 2 is traveling opposite to body 1. Yes or no? Yes or no, students? If that is the case, can I take U2 as minus 3 meter per second? If that is the case, then initial momentum comes out to be what? 0. How? We know that this is 5 into 3 plus M is 5 and minus 3. Then we get what? Pi to be 0. Initially, it won't be 0. See, over here, since it is going to what? Travel to with each, I mean, it's traveling opposite to each other. Then we get what? Initial momentum to be 0. Because what? Since we are considering same mass and same velocity. है ना? अगर डिफरेंट वेलोसिटी हो तो आंसर अलग आता है ना. पी इनिशियल वेलोसिटी, इनिशियल मोमेंटम तो जीरो ही नहीं होता. यस स्वीटी, लेट मी नो. यस और नो? ओके, वेरी नाइस. नाउ वी नो दैट इनिशियल मोमेंटम इज इक्वल टू फाइनल मोमेंटम. कंजर्वेशन. यस, कंजर्वेशन ऑफ मोमेंटम की वजह से आपको पता है ये जीरो है, तो पी एफ इज इक्वल टू जीरो है कि नहीं? आपको ये चाहिए कि व्हाट विल बी द वेलोसिटी ऑफ कंबाइंड ऑब्जेक्ट आफ्टर कोलिजन. ठीक है, क्या होगा कि आपका जो कंबाइन है उसका जो कोलिजन होगा, जब एक कोलिजन हो गया ना, दिस इज कोलिजन, कोलिजन के बाद जो वेलोसिटी आ रहा है वो क्या है, आ रहा है कि नहीं? नाउ यू नो दैट व्हाट m1 v1 plus m2 v2 equal to 0, yes or no? Now you know that इसका जो क्या वेलोसिटी सेम होगा ना, तो क्या होगा m1 plus m2 into v is equal to 0. जो v आएगा ना वो 0 आएगा ना, 0 मीटर पर सेकंड आएगा ना. इसका मतलब क्या है, देखो v तो 0 मीटर पर सेकंड आ रहा है, इसका मतलब क्या है, the body or the system will remain there itself after collision. बस v0 आएगा, इसका मतलब क्या आ रहा है कि बॉडी आ रहा है, कोलिजन हो गया, कोलिजन होने के बाद क्या आ रहा है कि वो वही है, इट डजंट मूव, देयर इज नो एक्सेलरेशन फॉर इट. इज इट गुड नाउ? इसलिए आपका जो भी वेलोसिटी आ रहा है ना वो 0 आ रहा है, पता चला अभी? इज इट गुड स्टूडेंट्स? नाउ द आंसर वाज व्हाट, 0 मीटर पर सेकंड. And everyone very good for answering it. Amrita, yes, good. Amrita, very good. Others, let me know. Understood, very good. Path, others, tumko students, yes, very good. So that's all for today, students. Yeah. So before ending our session, let us talk what we have studied today. The first thing we talked about what this some like last class recall, where we talked about what impulse. We saw what is impulse. And also I have given you homework question. होमवर्क क्वेश्चन दिया है ना, है कि नहीं? ये याद से करना, ठीक है? आई एम गोइंग टू आस्क टुमारो. फिर व्हाट वी टॉक, हाउ टू से, वेरी गुड. देन वी टॉक्ड अबाउट व्हाट, न्यूटन्स थर्ड लॉ. व्हाट डज न्यूटन थर्ड लॉ सेज? Action reaction, yes or no? For every action there is a reaction, that is what action reaction pair hota hai. Then we saw what are the important nodes for action reaction, what forces. So in order to call a force to be action reaction force, we saw nodes, yes or no? There was what, 4 nodes, 4 points basically. Then we talked about what, conservation of momentum. Yes, where we saw that the final momentum, initial momentum is equal to the final momentum if there is no external force. Is it good? Yes. So students, that's all for today. If you have any doubt, let me ask, letting you to ask me. Okay students, so thank you for attending. Let's see you in tomorrow's class. Yes Abhay, I do use. Dhanyavad. Okay, take care. Bye bye students. YouTube live students, take care. Bye bye.